Hey, welcome back. Let's talk about division now and what that means in terms of blocks of numbers and also a few things to think about with division on a computer. So, division. We firstly have been thinking about numbers in terms of blocks, just kids' blocks, if you like, building blocks, bricks, whatever you want, just blocks, okay? So if we have the number 8 thought of in terms of blocks, dividing this, if you divide it by 2, the way to think about that is splitting it into 2. So you can see from the drawing I've just made that if we divide 8 into 2, we get 4. So 8 divided by 2 equals 4. That's what that is kind of graphically showing us, okay? So 8 divided by 2 equals 4. Now, by the way, you may see this written lots of different ways, and we'll go through those in just a moment. All right, now let's look at the other division of this same thing, which is saying, okay, well, we've got 8 here, but we're going to divide it by, in this case, 4. So we have 8 because we've got all this business here. But now we're going to say 8 divided by 4. I know this is sucking eggs for a lot of you, but we're building some strong foundations here, so just stay with me. So 8 divided by 4 means we're splitting it into 4 parts. Now, it's very common in computing to do something called an off by 1 error. So there are 3 green lines required to split it into 4 parts. So like with fences and fence posts, you need 1 more fence post than you have fence panels, right? So this is just like a fence on its side. It's the same kind of idea. So be careful with off by 1 errors. Always be thinking about, do I mean I'm starting at 0? Do I have 1 more or less than maybe I think I have? Anyway, we're dividing this 8 into 4 regions, and that gives us 2. It's saying that in each region, I've got 2 things, whereas when we divide by 2, we've got 4. So what this is telling us is that division, the order matters. Just like in subtraction, the order matters. In division, the order matters. If we do division around the wrong way, then we are going to get a different result. So, for example, if I now do 2 divided by 8, what do I have? Well, I'll draw the 2 a little bit bigger just so that they're not kind of disappearing into obscurity. But there's 2 here. And if we divided that by 8, how would that go? Well, if we wanted to do that, we'd sort of have to split each of these up into 4 different parts. So there's 1, 2, 3, 4. And then this other one also would have another 4 like this. Now, I should actually have 7 lines if I'm dividing into 8. There you go. So if I take 2 and divide it by 8, I'm actually going to get a fraction of a number. I'm going to get a part of a block. How much of a block am I going to get? 1/4, because there's 1, 2, 3, 4 quarters here. Okay, so 2 divided by 8 equals 1/4. So before we move on, let's just make sure we understand what we mean by 2 divided by 8 equals 1/4. It's not just a notational thing, whereas this divided is the same job as this, but we're also doing something else. All the numbers have changed, so just take a moment to make sure this makes sense. Let's draw 2 divided by 8 a different way. So these 2 white boxes are going to represent the 2. And what I'm going to do is take a green colour and divide that up into 8 like this by dividing through this way here and then along there. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's basically exactly the same as we've just done above, but just depicted a little bit differently. So what we could say is that if we were to do that and split these things up, they're going to separate out something like this. You're going to end up with 2 separate holes. Each one of those holes is split into 4 different things, right? So the way that 2 splits up into 8 is you end up with these little green bits here, and that is that quarter of a whole. You can now see visually that taking 2 whole things, as I have on the left, and dividing them into 8 is the same as taking 1 whole thing and dividing it into 4, in terms of the little things that you end up with. And it's the same in the diagram above here. We took 2 whole things up here, we divided them into 8, and that was like taking 1 whole thing here and dividing it into 4. All right, I hope that makes sense for you. Let's look at it one other way, just for people who think a little bit differently. So if we were to take 2 divided by 8 and divide it by 1, what do we get? Well, if you ever divide something by 1, you're kind of doing nothing. So we get 2/8, all right? So another way of saying this is if 2/8 divided by 2 divided by 2, because 2 divided by 2 equals 1, right? So I've just taken this 1 and represented it a different way. This, by the way, is where the creativity comes up in maths. You decide to do things like this because it proves a point. Okay, must still equal 2/8 because this equals this, 1 equals 2/2, everything else must be the same. That's how equations work. Now we can just divide each of the things. So we can say that 2 divided by 2 equals 1, and on the bottom, you're allowed to join these things. 8 divided by 2 equals 4, which must equal the 2 over 8, because what was on the left must be the same as on the right. So there's kind of a mathematical way of showing that 2 over 8 equals 1 over 4, and there's kind of a visual way of showing that they divide up to give the same little bits. So hope that's helpful to you. Let's scrub it out and carry on. There's actually a relationship. If we swap these around and get them around the wrong way, we end up with 1 over the thing we were looking for. So that's the consequence of doing division by the wrong way. The result ends up the wrong size. With subtraction, it ends up the wrong sign. For example, 2 minus 3 equals minus 1, whereas 3 minus 2 equals plus 1. So with subtraction, you get the wrong sign. With division, if you get them around the wrong way, you get the wrong size. All right, so that is what happens with division. Now, this number space that we talked about before, this still applies, by the way. This tool that we had where we said, okay, we've got two different numbers. We're going to call them A and B, and we're going to talk about plus A and plus B and minus A and minus B, and we're going to talk about the general case of going A divided by B equals C, or just A divided by B. What's going on there? Well, if A and B are positive, what does a positive divided by a positive equal? Well, you guessed it, it equals a positive. Okay, if we take a positive number along here and divide by a negative number, what do we get? So let's draw in an example. For example, 4 divided by minus 2, where the B is minus 2, what do we end up with? We end up with a negative number, and it's going to be negative 2. Minus 4 divided by minus 2, what does that equal? Well, that is going to equal plus 2. It's the same quadrant that we used in the multiplication video, and the same goes for their exercise to the reader to generate yourself an example of a negative number times divided by a positive number. Okay, so this quadrant holds and works in this case as well. So that's pretty good news, and it's going to be super handy when we get to angles and the like. So let's dive over to the computer for a minute and just look at a few other notes on division for you. With plus and times, the order doesn't matter. It doesn't matter which order you do them in. But with subtraction, the order matters. It affects the sign of the answer. You're going to get the opposite sign. You're going to get a negative if you do it the wrong way. And with division, and that's another way of doing division on a computer, we tend to use a forward slash. Order matters again, and it'll affect the size of the answer. So the next rule is thou shalt not divide by 0. We'll talk about that a little bit more later because it's a bit subtle and we have to understand how functions work and stuff in order to think about what happens if you try and divide by 0. But it will blow your brain up, and it blows mathematicians' brains up, so we just generally don't do it. And know that on some computer systems, a divide might be slower than a multiply, but it actually depends on your hardware. So it's worth looking that up and knowing where you are, whether you should be dividing or multiplying. So for example, if you want to halve something, you could multiply by 0.5, or you could divide by 2. And if speed matters to you, just look up and find out which your system is faster at. A couple of other points. With plus and multiply, you're tending to make things bigger, so you may run out of range on your number. You may not be able to represent the size of the number. With minuses and divides, you tend to end up running out of precision. With minuses, actually, you could run out of range as well, because you could be going so negative that the number gets too big and negative. So just be aware of all the normal pitfalls. With the same as addition and subtraction, computers don't support every single number that's out there. So here's a quick pop quiz for you for the end of the lecture. Now, don't spend too long agonizing over this because it's designed to be annoying. The actual question is almost invalid because it's not got enough information in it. We'll see more of that later when we look at brackets and things. But if you take this expression here, 9 minus 3 divided by a third plus 1, what does that equal? Have a little chat in the discussions about what it might equal and why it might equal that. But let's not get into much of a right and wrong argument. Really, I'm telling you from the start that the question is kind of wrong in that it doesn't really give you enough information. It's ambiguous. If it creates discussion, it's ambiguous, and there are ways of making it less ambiguous, which we will see later. So anyway, brief primer on division of whole numbers, and we'll come to fractions and decimals and things like that later on. But hopefully that gives you some insight. Hopefully you've learned something. If you're familiar with maths, just pop in the comments one thing you've learned that you didn't think about division before, and I shall see you in a bit.